Hi everyone. Now in this video we're going to focus on how to solve problems pertaining to thermal properties of matter, and that will involve temperature change and a change of state. Now given this problem, a mass of 20 grams of cold water is at 273 Kelvin. It is added to 100 grams of water at 308 Kelvin. And this 100 grams of water at 308 Kelvin is actually inside a copper calorimeter of mass 50 grams. The initial temperature of copper calorimeter is also 308 Kelvin. What you're asked to do is to find the final steady temperature. Now, note that the temperature given are all in Kelvin. Now, because we are more familiar with the temperature in degrees Celsius, and we need to know whether the boiling point or the melting point of water has reached. So we'll take 273 Kelvin, convert to degrees Celsius will give us 0 degrees Celsius. 308 Kelvin will give us 35 degrees Celsius. And since the question stated that cold water is at 0 degrees Celsius, so that means at 0 degrees Celsius, this is not ice, this is actually water. So we don't have to worry about melting. And the water is at 35 degrees Celsius, so that means there's not going to be any boiling involved. Since the cold is at 0, high is at 35, the final temperature has to be somewhere in between. And hence, the water is not going to reach boiling point or melting point. And because of that, we know the question will not involve specific capacity of fusion or vaporization. So far what we know, we let the final temperature be T. So water at 273 Kelvin will gain heat, and its temperature, change in temperature is T minus 273. And the water at 308 Kelvin will supply the heat, and the change in temperature is 308 minus T. There's another substance which is a calorimeter. You supply the heat since its temperature is at 308 Kelvin, so the change in temperature will be 308 minus T. Again, let us structure the data so that we can solve the questions more easily. And I also like to emphasize, it will take time, but this investment is worth it. Because you want to focus on solving the problem. You don't want to spend time figuring out which number goes to which part of the equation. And hence, writing this structure down is much more efficient. So for a start, we let T be the final temperature reached. And in a small given space, we're going to divide the space into two parts. One part is the heat supply and the other part is the heat gain. So for the heat supply, this is actually water at 308 Kelvin. So the data is all there, M1, C1, change in theta 1. The other one is the calorimeter. The copper calorimeter, the mass is 50 grams, so you M2, C2, and change in theta 2. So the only thing that's gaining heat is actually the 273 Kelvin water, which is essentially 0 degrees Celsius. And all the data is given there, M3, C3, change in theta 3. And to solve this problem, one thing to note, the specific capacity given have kilogram in it. And hence, all the masses that we are given, we convert to kilogram first. We convert it during laying out the data. So this will help us speed up problem solving later. So from principle of conservation of energy, we have heat supplied by 100 grams water plus heat supplied by calorimeter equals heat gained by 20 grams of water. And hence we have M1C1 change in theta 1 plus M2C2 change in theta 2 equals M3C3 change in theta 3. Sum in the values. As mentioned earlier, this is a physics lecture. This is not a maths lesson. So I'm not going to show you how to manipulate the equation to get T. You should get your value of T to be 302.4 Kelvin. Like I said before, if your answer is more than 4 decimal place, if your answer is more than 4 SF, please present it in 4 SF first, because you do not know whether you need that value later on. Get into the habit of presenting in 4 SF first, and then change to 3 SF as your final answer.